I want you to imagine something small and ordinary. A single drop of ink falling into a glass of water. For a heartbeat, the ink is a cloud of possibilities, threads of color that could swirl this way or that. Then the water moves, molecules jostle, and the swirl becomes a single, visible stain. The stain did not appear because someone looked at the glass. It appeared because the water itself kept 1,000 tiny notes about where the ink went. I tell that story because, as a physicist, I have spent my life listening to the way the world keeps notes. We call that process decoherence. It's a mouthful of a word, but the idea is simple and strangely beautiful. The universe writes itself down again and again in the smallest of ways. Those tiny notes, like collisions, scattered photons, nudges of molecules, add up until the many possible stories of a quantum system stop talking to each other. One story becomes the one we call real. You might ask a question. What about before those collisions, before the environment, taking those tiny notes? Does the quantum system in a quote-unquote unreal state? Well, if by reality you meant the classical, ordinary experience we have, then the answer is yes. At the smallest scales, the world does not behave the way we expect. Objects are not simply here or there, moving along definite paths. Instead, they exist in a kind of suspended ambiguity, in a cloud of possibilities. A particle can be in multiple places at once, not in the sense of being smeared out like fog, but in a deeper sense. It simply does not have a single, definite position yet. It is not that we do not know where it is. It is that the question itself does not have a single answer. Physicists call this a superposition, but I prefer to think of it as a kind of private reality, a reality that has not yet committed to a single story. So why we never see this in our everyday experience, why we never see chairs that are both here and there, cats that are both awake and asleep, a world that flickers between possibilities, the usual answer you will hear is measurement. When you observe a system, the story goes, the possibilities collapse into a single outcome. But over the past decades, we have come to understand something subtler. Measurement is not special. It is not the act of a conscious observer that makes reality snap into place. Instead, something far more mundane and far more relentless is at work. The universe is constantly interacting with itself. Light bounces, air molecules collide, heat flows, fields fluctuate. Nothing is ever truly isolated, and with every interaction, something important happens. Information spreads. Think about a dust mote floating in a sunbeam. It's tiny, but it scatters light. Each scattered photon carries a sliver of information about the mote's position. One photon is a faint hint, 1,000,000 photons are a photograph. The more photons that scatter, the more the environment agrees on where the mote is. The mote's position becomes a consensus, not a decree. This consensus view changes how we think about uncertainty. Uncertainty is often framed as ignorance, something we lack or something we do not know. But in quantum physics, uncertainty is also a space of possibility, a place where the universe has not yet written its notes. When the environment writes, uncertainty shrinks. When the environment is quiet, for example, in a deep vacuum, at near absolute zero, uncertainty can persist, and quantum possibilities can sing and dance together. That's why physicists go to such lengths to isolate systems, to keep the ledger blank long enough to hear the quantum chorus. This is also why the world looks classical. Not because quantum possibilities disappear, but because the billions upon billions of interactions make the possibilities inaccessible, scattered into the environment in a way we cannot reverse. Here is the key point. The system does not become definite because someone observes it. It becomes definite because information about it has spread so widely that it cannot be gathered back because it is leaked. In that sense, reality is not simply what exists. It is what has become irreversibly public. There's a beautiful and slightly unsettling consequence of this. Imagine a perfectly isolated system, completely cut off from the rest of the universe, no light entering, no particles leaving, no interactions at all. In such a system, quantum possibilities would persist. The system would not choose a single outcome. It would remain in its cloud of potential, not because it lacks reality, but because its reality has not yet been shared. This is where the title comes from. The universe is not real until it leaks, or more precisely, what we call real is what the universe has been forced to commit to through the spreading of information. This is decoherence I mentioned earlier. It has a moral, almost poetic consequence. It suggests that what we call reality is the world that has been recorded enough times to be unambiguous. Reality is not a single fixed ledger kept in one place. It is a consensus built from countless tiny records. It's a social process. But the society is made of particles and fields. There is another way to say this, one that I find even more striking. The universe does not keep secrets. Every interaction is a kind of recording. Every collision leaves a trace. Every photon that reflects off an object carries away a tiny piece of its story, and those pieces multiply, scatter, and amplify until the information becomes redundant, copied again and again into the environment. At that point, the outcome is effectively locked in, not because of a fundamental collapse, but because too many witnesses now exist. And this is why reality feels so solid, not because it is inherently so, but because it has been over-recorded. Think about the chair you are sitting on. Light has bounced off it trillions upon trillions of times. Air molecules have collided with it endlessly. Heat has flowed through it. Its position, its shape, its state, these are written into the environment in countless ways. To change it, to make it ambiguous again. You would have to undo all of those interactions. You would have to gather back every photon, every molecule, every trace. In practice, that is impossible. And so the chair feels real, but at the deepest level, that solidity is not fundamental. It is the result of a process of leakage. There is something almost poetic about this. We often think of reality as something private, intrinsic, self-contained, but physics suggests the opposite. Reality is relational. It emerges from connections, interactions, and shared information, and perhaps that resonates beyond physics, because even in our own lives, what feels most real is often what has been shared. A memory becomes more real when it is told. An idea becomes more real when it spreads. A moment becomes more real when it leaves traces in others. Of course, we should be careful not to stretch the analogy too far. Quantum particles are not thoughts, air molecules are not gossiping, but the structure is similar enough to make you pause. We live in a universe where nothing remains entirely hidden, where every interaction leaves a mark, where every possibility is gradually forced into a single narrative, not by observation, but by exposure. So the next time you look at something, be it a tree, a table, the face of someone you know, consider this: what you are seeing is not just an object. It is the end result of an immense cascade of interactions, a story that has been told, retold, and written into the fabric of the world until it could no longer be anything else. And somewhere, beneath that solidity, the quantum world still hums, full of possibilities, waiting not to be observed, but to be shared.